Hello friends, welcome back. Today I have brought this question from NDA 2013 paper 2. So let's read the question first. Before starting, I just want to tell you that this question is based on the momentum conservation theorem. Okay, if you already know what momentum conservation theorem is, then you can try to solve this question on your own and write your answers in the comment section. So let's read the question, and in between I'm going to tell you what momentum conservation theorem is. Okay. So a bullet of 20 gram is fired. See, they have given the mass of the bullet, okay, which is 20 gram. Now it is fired in the horizontal direction. So we will be considering the linear momentum case in this one. Okay. Now they have given us the velocity of the bullet after firing. So it is 150 meter per second. Now they have also mentioned the mass of the pistol. Okay, and at the end we have to find the recoil velocity. Now those who don't know what a recoil velocity is, let's say this is a bullet. Let's say this is a bullet. Okay, now when for example you are firing a bullet from this pistol, okay, you might be playing for Diwali or something. So when you are firing the bullet, you might have felt a jerk in backward direction, a jerk of hand in backward direction. That jerk or that velocity with which your hand is coming in backward direction is called as recoil velocity. Okay, so it is the velocity with which the pistol is going to come back in the backward direction. Okay, and bullet is moving, let's say, in this direction, in forward direction. So from the Newton's third law of motion, you can say with every action there is an equal and opposite reaction. Now in this case, moving of the bullet in forward direction is the what is called as the action. And what will be the reaction? Reaction is the movement of pistol in backward direction. Okay, so law of conservation of momentum is based on the Newton's third law of motion. This was the this was the momentum conservation theorem. Now in the question, let's write down first of all what is given to us. Okay, what I'm going to do, and which I will suggest you to follow, is make two columns whenever you are getting this type of problem based on the momentum conservation theorem. Just make two columns. Okay, I'm going to draw two columns over here, let's say, and in one column I'm going to write the velocity and mass of the pistol, and in second column I'm going to write the mass as well as the velocity of the bullet. Okay, so this will be for gun and this will be for bullet. It will be easier for you to differentiate when you will be using the momentum formula. Fine. So mass of the gun is given to you, which is here. So I'm going to write down mass of the gun is 1 kg. Okay. Now mass of the bullet is also given to you. So I'm going to write down mass of the bullet is equals to 20 gram. See, this is in grams. So we have to convert this into its SI unit first. So I'm going to convert it. In order to convert grams into kilogram, I'm going to divide this term with 1000. Okay. And then it will get converted into kilograms. So it will be 0.02 kg. Fine. Now in momentum we know we will be dealing with velocities. Okay. So let's say the initial velocity of the gun is 0. Okay, you are holding the gun, so its initial velocity, it was not having any speed, so its initial velocity will be 0. And let's say the final velocity, I'm going to represent it with small v. It is also called as the recoil velocity. This we have to find out. Okay, and for bullet, again let's write down the initial velocity of the bullet. Since it was inside the gun and gun was at rest, so we will say the bullet was also at rest. Okay. Now let's write down the final velocity of the bullet. It is already given to you in the question here. As you can read the question thoroughly, you will be able to find out that this is the final velocity with which the bullet is moving from the pistol. So I'm going to write it down. It is 150 meter per second. Fine. Now we have got the masses, initial velocities as well as the final velocities. Let's find out the unknown factor over here. Okay. Now I'm going to write down the formula for total conservation of momentum. Okay. So I'm going to write down according to law of conservation of momentum, or you can also say linear momentum. Okay, because it is in a line and we are also taking it in one direction. Okay, so according to the law of conservation of momentum, I can write it down that total momentum before collision is equal to the total momentum after collision. Now what collision is? In this case, I will say that collision is the firing of the bullet from the pistol. Okay. Now if you know what total momentum before collision and after collision is, you will be able to find the unknown term. Okay. So after this one, I'm going to write down the formula. Okay. So total momentum before collision, it will be the initial momentums, the sum of initial momentum of gun as well as the bullet. So let's write it down. mg into ug. This is the initial momentum of the what? This is the initial momentum of the gun. Okay. Plus the initial momentum of the bullet. This is the sum of initial momentums. Now, if I want to write down the final momentum, I'll write it as mass of the gun. It is not going to change. Mass of the gun into the final velocity of the gun plus mass of the bullet into final velocity of the bullet. Okay. Now let's put the values and we will be able to find the unknown one. Now remember this thing, since initial velocity of gun and initial velocity of bullet is 0, so I'm just going to put these two terms as 0. Okay. So this whole term in the left hand side will be 0 is equals to mass of the gun is given to us, which is 1 kg into velocity of the gun, which we have to find out, plus mass of the bullet, which is 0.02 kg into velocity of the bullet, which is 150 meter per second. Now I'm going to rearrange this one. I'll put this in the left hand side and there will be a minus sign. Okay. So it will be minus Vg is equals to 0.02 into 150. This minus sign I can bring on the right hand side and it will become Vg is equals to minus 3. If you will multiply this, you will get minus 3 and the unit will be meter per second. Now, I guess you might have got how we are going to find out the velocity, or you can say the final velocity of the gun. Okay. So this is it. Those who have done the answer correctly, I hope they are going to watch the another video, and those who have not solved and they were not able to answer the question according to this law, I would suggest them to go through this question once again. Okay. And you are going to do good in your NDA exam. Thank you. Also, you can also find it as the answer is also given to you in the option section, which is minus 3. Okay. Now this minus 3 represent, you can see that A is the correct option, 3, Okay, the magnitude of the velocity is 3 meter per second. Minus sign beta, it represent that velocity is in negative direction or in backward direction. Minus sign is the indication of the direction in this case. Okay. Oh, I hope you have understood the question. So please do like and subscribe our channel, and for more videos please follow and follow the NDA math series as well as the physics series. Thank you.